1 more minute till we get started. All right, at this time, I'm going to need your full attention. Take your headphones off. You should be moving out of the bell work. You can put it to the side on a different tab. But you're going to need to get focused in for the lesson because we are going to go ahead and start the new lesson. This is the last lesson of the unit, so I will need your full attention. This has the most content. It's not the most difficult, but it has the most content of any of the lessons. So, real quickly, as we get started, first off, I have a schedule up here so you know what's happening. Today, final lesson of the unit. So the last topics that are going to be tested, I'm telling you today on your Unit 8 exam. Welcome back. Friday, I'm going to be proctoring for the FAST or the EOC. I don't know which one it is, but it says on the schedule FAST/EOC during second and fourth period. So you will be practicing. I'll have practice questions for you to do on Friday. As always, when you are asked to work on practice, you are allowed to work together. You can work in small groups of 2 or 3. Make sure you're all understanding what to do. The purpose of practice is understanding, like I said earlier today. I want all of you to do well. But in order to do well, you've got to do a lot of practice because that's how you build those connections. And so Friday's going to be a full practice day, but you'll be practicing either in here or in the media center. I'm not sure where, but I'm most likely proctoring that day according to the schedule. If things change and I'm here, you're still practicing that day, regardless. On Tuesday, this is the full review day where we do quizzes, we do gym kits. I'm working on making a gym kit for it, and we'll be practicing for 2 straight hours that day, practicing organic chemistry, everything that we learned from lesson 1 to lesson 4, because again, it's about building those connections and making sure you're understanding how to do everything. And then on Thursday, you'll have, as always, like a first 30, 45 minutes, you'll have a little bit of time to practice, warm up. I don't like giving you exams right at the beginning of class in the early morning, especially. So that will be the day, though. That is kind of the final big day for this course because that's the day of your Unit 8 exam. That's going to be Thursday, May 23rd. So next week, Thursday. Try not to miss that day because it's going to be difficult for you to make up that test. Because remember that next week, this room is going to be shut down. So I'll tell you on Google Classroom when you'll have the opportunity to make up whenever I'm available for you to come by. But largely, it will be difficult for you, and you may end up having to take a test the first week of June, which I know you don't want to do if you don't take it on that day. So make sure you try to make it to school on that Thursday, May 23rd, so you can take that last test on Unit 8. Unit 7, some of you have to still take that test or need to take the makeup test. I told you you'd be allowed 1 retake if you did all of the practice problem sets that I posted. So if you did all the practice problem sets on quizzes that I posted and you got an 80% or higher after your 3 attempts, then you can do 1 retake for Unit 7. There's no point in doing a retake if you didn't practice because you're not going to do better. I promise you. After time, you're going to do worse. And I want you to do better. The purpose of a retake is to do better. So you would have to take all the practice problem sets in order to do a retake, if that makes sense. Times available to do that. Next week, Monday and Tuesday will be the next opportunity to do a retake. So there won't be regular tutoring for the rest of the school year, pretty much for this course because of all the lab exams that are taking place. But you can still come after school next week, Monday or Tuesday, to do the makeup test or retake. And if you know you're not going to be here Thursday, May 23rd, but you want to take the test early for Unit 8, you just have to let me know in advance. And you can also do it next Monday or Tuesday. Yes, Daniela? Your last game points update will probably be emailed to you in the week of Memorial Day. Most likely. That's how it's going to go. You're welcome. For Game Boy redemptions, remember that if you don't redeem, if you're over 200 points, I'm going to give you a gift card. And if you're under 200 points, I'm going to apply it to your grade. That's how it's going to go. If you don't redeem your game points by the deadline, and the deadline would be the week of Memorial Day. And you have to send me an email. I'll give you an update next week on Tuesday of when exactly you can redeem for like public subs, because there'll be limited days that I'll be going out for that. But there'll be a few days that you can choose from. All right, so that's all the class announcements. Let's get to the final lesson of the school year for this class of pre-AICE chemistry. So final lesson, here we go. Today we're going to be doing, it's a major topic actually for future study in either chemistry or biology. So anybody who's doing any type of science major, medical major, nursing major has to know this topic very well. And so this is Unit 8, Lesson 4. It's called Functional Groups. So you have received a copy of Unit 8, Lesson 4 as you were working on your bell work. Like always, track along, take notes as you see, as you see me solving questions, make sure you are going through and solving the same questions. Yes?
I'm sorry, pardon the interruption.
Yes? Yes?
Do you have Young Lady Martinez?
I do. Yes?
Can you send her to the main office? She'll be back in a minute.
Okay. All right, so I want you to underline the word function here, or highlight the word function here. A functional group changes the function of the organic molecule, meaning it changes its reactivity, it changes its actual chemical and physical properties. A lot about the molecule is dictated by the functional groups on the molecule. And so today we're going to learn the different types of functional groups, the major functional groups that you are supposed to know. And the goal, like everything for this unit, is you're going to have to draw them and you're going to have to know them by name. So let's take a look. Unit 8, Lesson 4, last one. Let's get to it. I just have this on everyone. Turns out, alkanes are boring. I'm just going to write that. Alkanes are boring. Meaning, there's literally only two things that they can do. One that you know. They can be radicalized in something called a free radical reaction. You don't know that. That's taught in AICE Chem. And they can be burned. We can burn them. They're useful as fuels. So they're useful as fuels because they can be burned in something called a combustion, which is why you saw that combustion question show up in your bell work today, because they can be burned. So this is why your propane, your butane, all of that, they're all alkanes. They're hydrocarbons. But in organic reactions themselves, they're boring. They don't do much. They're not very interesting. They're not good starting reagents for making a drug or medicine. They actually, if you were to ingest them, they would be toxic. You should not drink gasoline, right? A functional group. So what a functional group does is it changes the reactivity and properties of an organic molecule and has characteristic organic reactions. And so a functional group changes the properties and reactivity of an organic molecule. This is ethane at the top here. Ethane. This right here is is called ethanol. Does anybody know what ethanol is? Yeah, it's used more than that. Can be used as an additive in gasoline, but it's also, ethanol is drinking alcohol. People who drink alcohol that are 21 and above years old, they drink ethanol. They drink small amounts of ethanol. But that is just with this OH group being here instead of this H, that gives it a completely different characteristic. You would not drink fuel, but some people would drink alcohol, which is technically fuel as well. There is in your hand sanitizer ethanol. This is 62% ethanol, actually. The hand sanitizer that we've been using. Ethanol. I would not wash my hands with gasoline, right? I would not clean my hand. I would clean it with hand sanitizer, which is ethanol. So the purpose of a functional group is it literally changes the function of the organic molecule just by changing one little atom. Here, all you've inserted is an oxygen, and it changes everything. Why does it change everything? What is different about that oxygen? Why does it change everything? Electronegativity. Because if oxygen is electronegative, that tells us a lot. This is now soluble in water, whereas this is not, right? This is soluble in water. This has a high melting point and a boiling point compared to this. That's what I meant by properties. So changing the functional group changes the properties, which you do not have to memorize at the previous level. I'm just letting you know that's what it does. It changes the properties and it changes the reactivity. So alcohols are much more reactive. You can do a lot more with them in terms of chemical reaction. So on the next slide, you're going to see the different functional groups you're going to learn about. 3 of them you already know. Just the good news. Halogen alkane. Put a check mark there. We did that last class. Halogen alkanes are technically a functional group. Remember, you have till the end of the day to work on that. So you need to make sure you're paying attention to the new ones. Halogen alkanes are one we've already done. Alcohols I just mentioned, but we'll go back over shortly. These are all the functional groups I'm going to expect you to know, actually. So that's why I said today has a lot of content. It's not necessarily difficult, but it's the most of any of the days. There's 2 others here you may want to fit in. I'm going to fit them in here. Alkene is technically a functional group and changes the end of the name to ene. Alkyne is also a functional group. Anything that changes the properties and the reactivity is something we call a functional group. So go ahead and add alkene and alkyne into the blank space. And so what we're going to do is we're going to break up each of these functional groups, go over what they are, a little bit of where they're useful or where they've been used, where you might have heard of them before, and how to draw them and name them. I hope you find it to be good news. For questions that you get with functional groups, I won't put any more than 1 or 2 substituents. I won't give you anything crazy like ethyl methyl propyl on all different carbons. I'm only going to keep it to 1 or 2 substituents if you have a functional group, because you're going to be looking for the functional group is the main thing and how to name it. For Cambridge, they only do simple naming with functional groups, meaning, once again, only a couple of substituents. So I'm not going to go too crazy here. Like some of those, don't know if you guys got that homework. You got like a bunch of stuff, but you did get the homework, which was for the Unit 8 Lesson 2 digital homework. Some of those questions were a bit wild. A little more wild than Cambridge would actually give, by the way. But good practice. Okay, this image right here. This has a story. After one of my A-level students in 2017 took their paper 4, they made like a little comic book, and the last slide was this cat with like these cyclohexane rings around their eyes. That's how they felt about the test. They got an A-level score on the exam. They did very well, but that's how they felt about the exam.
They should have made it.
Yeah, well, it was 2017. That's 7 years ago. All right, so we're going to take each of these functional groups because it could look overwhelming when you're looking at them all together. We're going to take them one by one. And so first one is called alcohol, which is the one you should be actually the most familiar with leading into this discussion. And alcohol is when you have a carbon connected to OH. So you're going to want to write that down. So if you see a OH connected to a carbon, that is called an alcohol. And I have some examples of what alcohols can be used for. It can be an additive in fuel. It's often an additive in fuel. When you have OH connected to carbon, that is what we call an alcohol. And so there's a few examples of common usages of alcohols here. It can be used as rubbing alcohol. Wait. You can use ethanol. You can use ethanol here. This is wine. Has some amount of ethanol in it. They classify it by percentages. How many percentage of your beverage is alcohol? And then this R right here, just to clarify what that means, R means carbon chain. And the way that I was taught it when I had first learned organic chemistry is you could think of R as the rest of the molecule, like everything else, anything else that's there. And so the rest of the organic molecule would be R, but it's the carbon chain that's attached to the OH. That's what R is. And so that's what it says here. R stands for an unspecified amount of carbons. It could be 1 carbon. It could be 100 carbons. R just means there's some amount of carbons. Yes, Damien. Hold on. Yeah, you're good. Take a pass. Okay. It stands for some amount of carbons, yeah. But not necessarily just 1. Could be 1, could be 100. Now, what you're going to have to know is the alteration to the naming strategy. If you've got an alcohol, you don't end the name with A and E. You end the name with OL. And that tells us it's an alcohol. So when you hear ethanol, that's supposed to mean to you that it's an alcohol, and S in the front means how many carbons? 1, 2, 2. So 2 carbon alcohol. That's what ethanol is. So I'm going to write a couple of examples. You're going to notice the next slide is blank. That's because I'm going to write some examples of how to draw displayed, structural, and skeletal for alcohol. So displayed for the first one. Let's do ethanol. So here's the displayed formula. This is ethanol. How would we turn this into a structural formula? What would that look like?
A line that has gray.
I'll wait. Yes.
CH3, H2, then.
So CH3, then CH2, then OH. Just the same strategy as always, where you take each carbon in the chain, you write all the hydrogens that are next to it, and then you go to the next carbon in the chain. Notice how OH is connected. It is just written next door, so it's CH2OH. The next one I'm going to show you in a moment is how to take care of if it's a substituent. Like what happens if the OH is a substituent. What would this skeletal formula look like? 1, 2, and then a line to the OH like this. You should write this down. That's the skeletal formula for ethanol. The next one I'm going to show you is, so this was ethanol.
So if it's CH2, it goes up.
I don't know what you mean by that.
Like when you get this skeletal formula, you have the CH3.
Goes like this.
Oh.
Or you could do that.
Oh, okay. So there's
Molecules are 3-dimensional. You just zigzag. Every line ending is a carbon. It's a zigzag. Now let's try one where you have a substituent, so you can see what that looks like in a different format. So I'm going to do propantuol. You see I have the name on the side. Propantuol is this. Propantuol has a common name. Its common name is isopropyl alcohol. Isopropyl alcohol is the one you use in your cups. It stings a lot, like if you use it, but a lot of our parents have had I don't know, when I was a kid and I got a cut or a bruise, my parents would have me put alcohol on it or hydrogen peroxide. And the type of alcohol is isopropyl alcohol because it's antiseptic. Yes. It will bubble because of the oxygen gas produced. Because it's reacting with your skin. Yeah, it destroys your skin cells actually. You're supposed to use the isopropyl alcohol, but it stings. So the hydrogen peroxide don't sting, but the alcohol stings. So what would the structural formula of this be? CH3. CH. And then if you've got, this is actually a substituent, isn't it? You should be putting parentheses around it in your structural format. So it looks like this, just like you would with a methyl group. If you have more than one atom that's coming out of the chain, that's a substituent, here it's the alcohol, right? Then you would put it with parentheses, and then you have CH3. Make sure you have this down because you are going to be asked to represent the different formats. And then what would a skeletal formula look like?
It would just be
1, 2, 3.
And then on that line you
And like
see OCH.
Important note about skeletal formula. In a skeletal formula, hydrogens are not drawn if the hydrogen is next to a carbon. Hydrogens connected to other elements, so you're going to want to write this down. Connected to elements other than carbon must still be shown. You're going to want to make that little note for yourself. It doesn't end with O, it ends with OH. So that's telling us when we see the OH there, that's the identifying characteristic that what you have is alcohol. Make sure you're writing this down, and then we're going to move forward. So alcohols are going to be treated like alkenes or alkynes, meaning we're going to change the end of the name to reflect that we have an alcohol. But the end of the name is going to be OL if I see that I have an alcohol. Ready? I'll give about 20 seconds. All right, let's go ahead. What's the name of this? Grab my highlighter. The molecule on the left, what will we name it?
I know.
How many carbons in a row? You should be getting comfortable with this.
Absolutely more. Like butane.
It's a 2-methyl. It's a 2-dimethyl butane with OH.
So, pay careful attention, like I said. Alcohol changes the end of the name like an alkene or an alkyne. If I have an alcohol, we're not going to say butane. We're going to say butanol. So, 4 carbons means but but because it's got an OH, it ends with OL. So here, the ending of the name is going to be buten 1-ol. That makes sense. Think about it. Why did I put the number 1 before the OL?
It starts out at the first carbon.
Because like everything, I got to stay where it's at, right?
Yeah.
This alcohol is on carbon 1. So you still have to follow all your same rules as before. You have to identify your longest carbon chain, identify your groups, number your longest carbon chain from lowest to highest, and whatever changes the ending of the name takes priority. So the alcohol has to be on carbon 1. So what would the name of this be? What here is on carbon 2? let's try the second one. How many carbons in a row for the second one? Seven, right?
It's a pentane.
Now I'm gonna circle my other stuff. Remember, we don't care about the hydrogen, we care about the other stuff. So I got something here. Put something here, I put something here, right? Those are my groups that I have to name. Now, which direction do I number the chain? Left to right or right to left?
Right to left.
Right to left. Because the alcohol has to be the lowest number possible. So this would be pentane, but it's not pentane. We drop the E and we add the new ending. Pentane what?
Pentane.
Pentanol or 2-pentanol. And then on carbon 4, what is there?
It would be 4, but I forgot what the number is for 1.
Man, easy feel dinner. 4-methyl. Pentanol. That was from lesson 1. 1 carbon long is not. Eddie and Alberto. All right, we're good here? Yes, move on. I'll give you 20 seconds. All right, we're gonna move on. So if you need to take a picture, please do so. This one is your turn. Try this one for a stamp. Can you name this correctly? I've shown you a couple. See if you can try this one. I'll leave this up until 8:37 and then we're gonna move on. There's not 5 carbons. That's not a carbon, that's an oxygen.
This.
This is not a carbon. This is a line going to an oxygen. This is carbon 1.
Oh, that's carbon 1?
Yeah. This is carbon 1. There's no carbon here. That's not OH. If I were to do the carbon backbone of this, it would look like this. This is carbon backbone of the same molecule. That makes sense.
No.
Can't have a 4-methyl if there's only 4 carbons.
Oh.
There's not 2 methyls. There's only 1 methyl. I wrote the carbon backbone just in case you're struggling looking at skeletons. If there's 4 carbons, you can't have a 4-methyl. So that will be on the end. There you go. All right. Very good.
So then how many methods?
There's not a methyl on carbon 2. Very good. Let me check. Yeah.
Can have another one of them.
Check in the back. Very good. All right, 30 more seconds and then I'm going to continue. You're welcome. All right, so the answer you should have gotten here was 3-methyl butane, 1-all. 1, 2, 3, 4, and this is the methyl group. Careful here about skeletal. This line is a covalent bond between a carbon and an oxygen. There is no carbon there. That is a place where a lot of students mess up. So I wanted to be clear about that. That's why I wrote the carbon skeleton underneath so that it makes it easier to understand. All right, we're going to move on. So alcohol is the one that you're going to see the most content with because it shows up the most often, to be honest, and also we can apply these principles for the other groups. So the next group is called amine, which amine is something you might have heard of before, and you actually should have heard of before. In biology, they're called amino acids. Amino acids are the building blocks of proteins. So that's why you see here like a bunch of proteins, because amino acids are the building blocks of proteins. The actual structure of an amino acid is this. Where this is the amine part of the amino acid. So an amine itself is an R group attached to NH2, which is what it says there. That's what classifies a molecule as an amine. Amines are derivatives of ammonia. Ammonia is NH3. And so it's a derivative of ammonia. And so they always have like a smell. It's not, I don't think it's the best smell. But amines have like a smell associated to them, like a fishy smell a lot of times. And also you can see that the name methamphetamine does come from the amine in it. Methamphetamine comes from the fact that there's an amine. The class of amphetamines have amines. And the reason why it's called meth is because there's a single methyl group hanging off of the amine. That's why it's called methamphetamine. That's the chemical structure. Exactly. I don't know. That's just common words because people don't understand. Like there's a lot of other molecules. Like there's methanol. There's a bunch of other meth molecules. So it makes people confused when they're looking. If you look at your hand sanitizer, you're like, it's methyl alcohol. Is that meth? No, it's not. That just means one carbon. You have to have this exact chemical structure is methamphetamine. If it's not that, it's not methamphetamine.
Ask for some meth and gets a piece
What?
of coal at the card.
Squiggly line means it can connect to other things. That's what, when you see a squiggly line, that's what it always means. Amines. So let's just look at an example displayed. We're going to do just one example here. CHHH, NHH. This would be a fully displayed amine. Yes. Can you go what? Yes. Take the pass with you though. Structural formula of this, same idea as before. CH3, NH2, skeletal formula, 1 carbon going to NH2. That's all that is. So this is called methylamine. Which is not methamphetamine. Methylamine. All right, so we're gonna go ahead and before I just wanted to show you this group. So amine means nitrogen. If you see N on your molecule, that means you have an amine. This is because it's a derivative of ammonia, and ammonia is NH3. The next group is called an ether. And yes, before I move on, you are going to have to memorize all the functional groups by next week, Thursday. That is the last goal. That's why I said this lesson would have the most content in it, and you're going to get 2 days technically of full practice on the whole unit, because you do need to memorize the functional groups by next Thursday. The next one's called ether. Ether. before?
Yeah.
Already heard of it.
Alchemy.
Okay. I know the first place that I heard of ether was before I learned chemistry. I heard it in video games. The Final Fantasy RPG person, and it's like, you know, a drink that you take.
I thought it was alchemy.
Like,
Oh, I don't think we did.
could be pronounced either way, I think. But I played like RPGs a lot, and after you take them for like extra magic points or whatever. But anyways, that's where I first heard of it. What it actually is it's an industrial solvent that's overall non-polar, so you use it instead of water as a solvent. So if you have organic molecules that are non-polar that you want to store, you use ether as the solvent. And so the characteristic of the ether that I need you to remember is that it's an oxygen sandwich. What do I mean by that?
Hey, you need extra sugar. So wait, could you say that water is in this?
There's no R group on water, so no.
And I feel like
'Cause
it
R
would
has
be
to be
safe
carbons,
to
right?
degrade.
So R, remember, is some amount of carbons. They have to have carbons on each side. But yeah, it's actually got a very similar structure to water, right? But because the R groups are non-polar, that allows for it to be used as a non-polar solvent instead of water being a polar solvent. So that's its main purpose. How you name it? You name each R group just for the length of the carbon chain, like it was a substituent, with ill, and then end with ether. And so an example of an ether, just so you can have an example, is like this. This is dimethyl ether. Now, there's been something sitting on this board that I've been waiting all year to talk about. If you're in the front of the class, you may be able to see it.
Yep.
It says you either get organic chemistry or you don't. Because you know you either get organic chemistry or you don't. And so now you know what that means if you've been looking at it.
No, you.
Ether.
We finally get the reference.
That's the reference that's been there the whole year. Because the name is ether. So like, you know, when you're taking the test,
It's like seeing a meme
either get organic chemistry or you don't. Oxygen sandwich, right?
it's like seeing a meme and then seeing the movie that the meme.
Oh yeah, yeah. I usually see the meme first. So we're gonna take a look at one example for ethers. What does the displayed structural and skeletal look like, just so we can see. So I'm gonna do one. I'm gonna do ethyl methyl ether. Ethyl methyl ether. So the one I've chosen is ethyl methyl ether. Let's see, how would we write this in structural? What would we do for structural form here?
You would write CH3 to CH2.
Three,
To
CH2.
CH3.
I don't see two options. CH2. Now what?
So,
Single oxygen, right?
yeah.
One oxygen. And then CH3. And how would this look in skeletal form? Two carbons goes to an oxygen, goes to a carbon. That would be the skeletal form of an ether. It's an oxygen sandwich between two carbon chains always.
Nobody says that, like, Gail says
That exists, yes. That you are responsible for naming? No. Just to give you an example, 11 would be umdake, and 12 would be dodake. Like, it would be like that. But not that anybody, even in organic chemistry 1 and 2 in university, and even in my advanced organic, what we do have to do is like know the different groups and functions. Ready? There's a whole gigantic book that exists of like all the organic names of all the different medicines, drugs, and molecules exist. And every time somebody makes a new medicine, you add it to the book. All right, carboxylic acid. This is another extremely famous group. That shows up a lot. Here's some examples of where you've seen carboxylic acid before, and what its actual structure is. Yeah, citric acid is a carboxylic acid. So the thing you gotta memorize about carboxylic acid is the COOH. makes a carboxylic acid a carboxylic acid. Specifically, you've got two extremely electronegative oxygens and this hydrogen hanging out here. I believe I asked you on purpose as a, well, not all of you got it, but one of the versions of the extra credit on the last test asked you about acidic hydrogens and to circle the acidic hydrogen on this large organic molecule. And you were supposed to recognize, and a lot of people got it right that had that version, that this is the acid. That's the H plus that would break off on a carboxylic acid because it's next to these extremely electronegative oxygens. So this is what makes the carboxylic acid an acid itself, is because it's that H is connected to two extremely electronegative oxygens, so it's easy for it to have the positive charge. And so a couple of examples of where you've seen it before. Citric acid. Aspirin's actual chemical name is called salicylic acid. That's its actual chemical name. And we could do a titration to figure out how much salicylic acid is in aspirin, actually. I might do that with my A level next year for fun. Yes. Grab the cups. But this is salicylic acid, actually. Aspirin that we take for pain relief. And vinegar. We did a titration with vinegar actually this year, and we found out the amount of acetic acid that was in vinegar. And if you were close, you got around 5%. It was 5% was what was on the label, how much acid is in there. And so this group is extremely useful. It's actually the other component of an amino acid as well. If we go back to what I had written about an amino acid, the reason why an amino acid is called an amino acid because it's got an amine and it's got a carboxylic acid. It's got this acidic hydrogen here. That's why we call amino acids amino acids. Anybody who's going to be studying AICE biology, I'm not sure if anybody in this class is moving on to AICE biology or not, but if you are moving on to AICE biology, you will be studying all of the different macromolecules, actually, and amino acid would be one of them. What? How what? So then, the important thing here is the naming strategy. When you have a carboxylic acid, the ending of the name is always acid. And carbon 1 is always a carboxylic acid. So circle that. When you have a carboxylic acid and you need to name it, carbon 1 is always the carboxylic acid. So if I give you this, what would the name of this be? Just to the ending will be now oleic acid. So what you do is, if it was 3 carbons, you would have said propane, but we drop off the last letter. We now change it to propanoic acid. I do not put a 1. Why not? Because we know it's always got to be somewhere. We don't put a number to say where it's at because we just automatically know it's on the end. You only put a number when there's an option of where the location would be. So this is propanoic acid. So carboxylic acid has got the acidic hydrogen next to 2 extremely electronegative oxygens. That's how we know it's a carboxylic acid. You're going to have time to practice this. Like I said, I'm initially presenting you the information today, but you're getting 2 full class periods to practice after this. I think Cambridge is kind of wrong because they want you to understand the implication that propanoic acid, there's only one option of what it could be. All right, so let's take a look at how does this look in all 3 formats. We'll use a simple carboxylic acid. So let's do ethanoic acid. This is actually the one that you titrated with, meaning you did your titration where you went from, if you were here that day and you went from the colorless to the hot pink and you went too far, or you went to the light pink, you were titrating strong base with this acid, actually, the specific acid. It's called acetic acid, but its actual formal name is ethanoic acid. It's got 2 carbons and it's got a carboxylic acid.
So it'll be
That's its common name. CH3 COOH or CH3 CO2H is the structural formula.
Yeah, I would start with the CH.
Both are accepted.
That's cool.
Because they both connected to the same part.
And they both gave the exact.
Exactly. So either of these are correct, and Cambridge presents in both ways. I've seen some questions they do COOH, some they do CO2H. So you better be familiar with them. Skeletal formula looks like this. It's a little bit interesting, but you're supposed to know that this intersection is the carbon that has both on it, and then that's the one extra carbon. So that would be the skeletal formula for ethanoic acid. Remember, hydrogens that are not connected to carbons do get written. Only hydrogens connected to carbons don't get written. This hydrogen is connected to an oxygen, we do write it, even in the skeletal form. Because it tells us, oh, that's a carboxylase. There's another thing with two oxygens that we're going to see very shortly. Okay, so that's carboxylic acid. Would the pH of a carboxylic acid be above or below 7? Below 7. But they're always weak acids, actually, so it'd be somewhere probably in 4. Let's name these. Couple examples. First one. How do we name this one? What has to be carbon 1? Is there a choice?
No, it has to be.
It has to be left to right.
It have to be the right mode for.
I don't have my hall pass back. Damien, did you bring the hall pass back? Nobody can go until my pass is back.
Oh, you put it on.
From the second time Damien left? Not there?
Wins.
All right. So, how many carbons long is this? Right to left. Carbon 1 is always where the carboxylic acid is. Because whatever changes the end of the name will get priority. So this is 3-methyl butanoic acid. There is no pass here. Where is it? Oh, Raven went. That's why. So no, not until Raven comes back. Next one. What would this one be? Carbon 1 is where? Left or right? 5-methyl. 6 long, so hexanoic acid.
Yeah.
You never say the carbon that the carboxylic acid is on because it's always on carbon 1. Like always.
Alright, this is
Okay. I'm just saying in general. All right, you can go now, Xavier. All right, your turn. Try this one. Horace Dan. Okay, you name this one. I'll give you, it's not one that should take very long, so by 9 a.m. You're missing the a.m. Remember, it's the alkene name, you just drop the E and you add the new ending. I'm giving till 9 a.m. Raise your hand if you want me to inspect for a stamp. You need a T. Pentanoic. A-N-O. the other part printed on what?
No.
Check. And the NOI. Alright, till 9 a.m. I'm checking. It's 9 now on my clock, so I'm gonna go ahead, check this last one, and then give you the answer. Alright, the answer for this one is 5 carbons long. There are no methyl groups. It's penta, noic, acid. Pentanoic acid. Okay, next is aldehyde. So the next set of groups is a little bit confusing because they look very similar to each other. So I would actually memorize them together. The next set of groups is called aldehyde systems. They both have this characteristic piece. Aldehyde, yes. An aldehyde, a way to remember it is that it's a carbonyl group, which is this. This is called a carbonyl. With the H on the end. So the reason it has the name aldehyde is because it ends with a hydrogen, aldehyde. So it's C double bond OH. This is the characteristic component of an aldehyde that you will be looking for. Now here's where you're going to be really careful. In the naming of an aldehyde, you drop the E and you add AL. How close are the letters A and O to each other in writing? Could you mistake one for the other if you're not careful?
Yeah.
Cambridge is extremely picky here. Make your A's and your O's your O's. Because ethanol and ethanol are two completely different. So here, I will be very picky about your spelling and that you use the right ending. This is the alcohol. This means something completely different. You gotta be careful right here. Alcohols end with OL. Aldehydes end with COH. With C double bond OH. Now, there's another group that looks just like them. They're called ketones. And the main difference is where the C double bond O is. You should note that aldehydes are always on an end carbon. Aldehydes are always on an end carbon because they got a hydrogen, so this means this is the end of the carbon chain. They are at the end of the carbon chain.
What's formaldehyde?
Formaldehyde
Yeah, but
is this. And we would call it methanol. That's formaldehyde. Methanol equals formaldehyde. That's what they use for like preserving dissection materials. Is this specific? It has a real smell to it.
yeah, I think we're right.
That is formaldehyde. And that's why. It's actually a double aldehyde. Got aldehyde on both sides. But it's called methanol. That's its formal name. That's how Cambridge would. They would not actually call it formaldehyde. They would call it methanol. Methanol, AF, today. So you got to be careful here with aldehydes. I'm going to tell you how to write their structural and their skeletal. You got to be real careful with this one. I'm going to use display for, I'm going to do ethanol. So at least we see a carbon here. This is ethanol. That's the one I've chosen. Ethanol. So what would this structural formula be? It would actually be CH3. And this is something that if you are going to take the AICE class, you are going to want to memorize, if not by the Unit 8 exam, CHO. Whenever you see CHO means aldehyde in structural format. It shows up with the hydrogen coming first and the oxygen coming second. They have a very distinct reason. People everywhere have a very distinct reason for switching the order and not putting the oxygen first. Yeah. Because if we put OH and we communicate that, most people will automatically trigger in their brain alcohol because it's a very common group. They'll think alcohol. So you have to switch the order of the letters for aldehyde. So it's CHO. CHO is aldehyde, is the way I remember it. And so the skeletal formula here, it looks fun. It's this.
Well, different life.
What?
Well, different life.
There is no other leg in the skeletal formula for this.
Yeah,
A ketone would have a leg.
It's an amputated person.
Why don't we draw the hydrogen in the skeletal form? Think about it. Hydrogen is connected to the carbon system, right? So aldehydes will appear at the ends of lines always. So there'll be a double bond like sticking out at the end of a line of carbon. That's how we know about aldehydes. Is what?
I thought it was
So the other group that's like aldehyde that I told you is very easy to get confused between the two. So you should practice the differences between the two. It's called a ketone, which you might have also heard of before. Ketone. Where might you have heard of them before? Believe it or not, your body will resort to ketone body metabolism in a process called ketosis. People do this as a diet. It is a very popular diet called the keto diet. And you'll see a lot of foods, if you go to the grocery store and you look at labels, they'll say keto friendly because it has a low amount of carbohydrates. So it basically takes and metabolizes your fats that way into ketones. Ketones have this general structure. You see it here, but it's going to be some amount of carbon, a carbon with a double bond oxygen, and then more carbon. So the main difference between a ketone and an aldehyde is a ketone has a double bond oxygen somewhere in the middle of the carbon. This is a ketone. Whereas an aldehyde has a double bond oxygen at the very end of the chain. That's the difference between a ketone and an aldehyde. So they look very similar to each other, but they're not the same. Yes. I don't know. I haven't heard of that. What is the context of that? I haven't heard of that. Ketone has a double bond oxygen somewhere in the middle of the carbon chain. Anywhere that's not carbon 1, then it's called a ketone. If it is at the end of the carbon chain, it is not called a ketone, it's called then aldehyde. That's the difference between the two. So it's very confusing because they look very similar to each other. But you just have to remember which one's at the end of the chain and which one's in the middle. Yeah. Where? Okay. I'm going to talk to you about the most famous ketone that you may be very familiar with. Maybe, maybe not. If anybody has ever painted their nails, and you've ever used nail polish remover, it has a very strong smell, it's called acetone. Acetone. And so the actual formal name for acetone is called propanone, actually. Propanone is our common acetone, which we use as nail polish. It's also used for like cleaning all kinds of things off of surfaces because it's very good at removing stains. So it's very smelly though. It has a very strong scent. If you've ever either taken nail polish off yourself or you have your brother, your sister, your mother, someone you know who has ever used it, it is a very distinct smell. One year, it was given as a qualitative analysis on a Cambridge exam, and I was like, they're gonna know what it is. you open the bottle, you're like, oh, nail polish remover, I know what that is. So a lot of times context can help. Like if you've seen things before you know them, it's like, don't think too hard. Propanol. Propanol means how many carbons? 3. If I told you this is a ketone, where does the double bond have to be? It has to be in the middle. And so the display would look like this. Butanone, there's technically only one option because if you've got 4,
Oh,
It's-
that's
reverse the other way. Starting at pent is where you have to put numbers because with 5 carbons in a row, you've got the option for 2 or 3. Structural formula for this is CH3, CO, CO. It's like this. CH3, CO, and then skeletal looks like this. Now you've got legs. Right?
Yeah,
Not
how
that-
do you just eat fruit? Did you have someone where both the ketone and aldehyde?
There are molecules that both have ketones and aldehydes on them. More complex, and you won't have to name them. There's an order of naming multiple functional groups. You can look it up. Cambridge does not. They only have you name with one function. All right, we're getting towards the end. I think we're close to the end, and then we'll practice. So ketone, most famous one is acetone. It does some cool things. If I remember on Tuesday, I hope I do. I'll bring some acetone and show you one of the cool things it does. What? What did you say? You'll see something.
Yeah.
No.
No.
You never
Ester. It is not that acetone. Acetone is not an acid. Don't do that. It's not even an acid. Ester. This is one of our last ones. I think our last one. One of our last ones. The ester group. This is actually a very famous one as well, and one that Cambridge definitely tests. If you study DNA, you'll see phosphodiester bonds. If you study linkages between different macromolecules, a lot of those linkages are ester bonds. But where you are most familiar with ester is in your clothing. You may be wearing esters right now. Ever heard of polyester?
Yeah.
That just means
Would that be
many esters linked
together?
together.
Does that mean that they're
Yes. So ester sounds a lot like ether because their structures are very similar. So remember, ether was this. This was ether. Look at the difference between ether and ester. They're almost exactly the same, but one has an extra double bond oxygen. So this is ester. So the characteristic part of an ester you have to have is a C double bond O, OC. Yes. It's available. You'll be the last to go. One of the ways I used to tell students, you can memorize it, is Esther also can be a name of a person. And this spells out cook. So you could say Esther is a cook. And that's a way to remember it. COOC. Esther is a cook. That's a way to remember it. So that's the main place where you'll have noticed that you may recognize Esther is polyester. So for Cambridge, what do we got to do? Name it and draw it. I believe I'm going to leave out naming it for the pre-ACE class. I cut out naming it, but for the ACE class, you would have to name them. The reason why I cut it out for the pre-ACE class is because it's the most complicated of the names. So I don't want to overwhelm you any more than you're probably overwhelmed. So you just have to be able to identify them and draw them. So let's take a look.
That's just what you
Poly typically means like many hundreds to thousands. So in the ACE class, when we do polymers, we just put a line around them and put a little N to say it goes on and on. We don't write all of that.
Would you say, or would like a shirt be?
Well, they're in lines, right? So they weave them in lines. So I think you would use multiple lines to put it together. You have to weave Nylon's another fabric. You could actually produce nylon through chemical reactions that can be done in the classroom. That's studied at the A level. Esther, let's take a look at this one. Display formula. So let's just do this, one of the simplest ones we can get. COOCH3. This is one of the simplest ones we can get. I told you I wasn't going to teach you how to name it this year. You just have to recognize them. So this is an ester because it's got the COOC. That's what makes it an ester. Structural formula here would be CH3, COO, or CO2. Either of those are fine. CH3. And then the other format is this. Both are accepted. Both of those. Skeletal would look like this. Looks like an ether, but you have an extra double bond oxygen. It has to be there for it to be an ester.
No, it looks like he's kicking a ball.
All right, so we're almost done. We're gonna do some practice questions now before we close out. And homework today, just so you're aware, is a digital homework. It is much easier than the last digital homework, I promise. It is just identifying different functional groups. So looking at, like you see on the next slide, and identifying what type of functional group you do have. 80% or higher, take a screenshot of it, and you get 100% of the grade book, like always. So I made that homework easier, but expect that next class you're gonna have 2 hours of practice questions. So that won't be as easy as the homework you're getting. I save the harder work for when you're in class. Identify the functional group in each of the following compounds. A, what's that? Identify means just tell me what's the functional group. Don't actually name it. Just tell me what's the functional group. You may want your highlighters again. Do you not have that question? So, what is it? Functional group practice. What is A?
I know B is
You've got an oxygen breaking up a carbon chain. It's an oxygen with carbons on both sides. It's an oxygen sandwich. That is it. Ether.
B is an alcohol.
B. You're looking for everything that makes it unique. Alcohol would just be OH.
No, I mean an acid.
This is COOH.
Yeah.
2 electronegative oxygens and a hydrogen is a carboxylic acid. Carboxylic acid. So this is carboxylic acid. Yeah. Has to have that exact. It's like its fingerprint.
It has the,
Has to have that exact component.
but it has the O to
This is the one we saw last class period. What is BR? An example of a? Bro.
It's a hollow.
It's a halogen, right? So we call it a halogen alkane. Alkane with a halogen on it. That's all that means. Halogen alkane. And then this last one, Z. Just the OH. This is the first group we talked about today, which was called an. So that's the level of the type of questions you're going to see in your homework today. Is identify the functional group. That's how I made it for today's homework. But I have, I believe, one more slide here I do, yes. I have one more slide. This is a summary slide that tells you all the different name endings you need to know. And I told you, I did this last year as well. I'm not going to test this in Create. Because there's 2 different names for the sides of the chain. So I'm going to wait to teach that till 8. But the others I am going to test the naming of that I've went over today. So Esther, you can cross out and be like, you don't have to do that either, not this year or never. I wanted to show you this because guess what? This is from AICE Chemistry. This is an AICE Chemistry question. Can you figure Penton 3L. Think.
Yeah.
1, 2, 3, 4, 5, 6. Carbon chain 6. Not 3. Right? It's penton. Think. 1, 2, 3, 4, 5. You've got the 2 fluoro and the 3 all. Here. It's in the middle, so it has to be 3 all. Because either way you number, it will be 3. And then you still never get that whole number of possible. That's why. The answer here is A. Okay, how is it? Oh. Alright. Last slide. We'll stop here. This will be our last one. Structural formula for hexanol. So what will we do? And it should say hexane 1 all, so fix it to hexane 1 all. 6 carbons. Structural would look like this. CH3, you could either write all of them, and then on the 6th carbon, this is the first, so we usually write it this way. 4, 5, 6, we do this. What else could you do? What could you condense? You could condense these. CH3, CH2, 4, CH2OH, because this is not exactly the same. So you have to say so that this is one of these. CH2. So that one would work. Hexane 3-one, how would we do it? 6 carbons, but on the 3rd one, you've got a double bond oxygen. So think about what that means.
That means 1 codon.
That's why I do the carbon backbone first. What does that mean? Does this carbon get any hydrogen?
No.
No. So our answer here would be CH3, CH2. Oh. See what I did?
Yeah.
CH2, CH2, CH2. You could do it like that too. You're allowed to condense as long as you still show the overall structural characteristics. And then hexanal. What would hexanal be?
Another 6.
6. And I always put my groups on the right hand end and then read them right to left because it's easier to look at. So CH3, CH2, CH2, 3, 4, 5. And on the 6th one, what do you have? Think about it. 1, 2, 3, 4, 5, 6. The aldehydes have to be on the end.
Yeah.
How do you write it?
HCO.
EHO. We'll stop here. All right, so work is online. Your homework for today. You'll have time to practice both on Friday and on Tuesday with everything from this unit. And then next Thursday is your final test for the year. For this class. A project. You have to do the cycle as your main chain. Daniela, do you have Mr. Akhtar? Yeah. He said you need to do your videos.